In a factory that produces widgets, it is suspected that the machine that fits the thingies to the widgets is not working properly. The quality control manager thinks about 5% of the thingies are incorrectly fitted. She decides to run a batch to find the first incorrectly fitted widget. So we're going until we get the first incorrectly fitted. Incorrectly, therefore, is going to be our success. And so what we have here is a geometric distribution. And the parameter for that is always the probability of success. Now, each Bernoulli trial here is going to have a failure then of 0.95 and a success of 0.05. Now, the first thing we're asked to do is find the expected number of correctly fitted thingies before she finds an incorrectly fitted thingy. As just discussed in the intro part 2, the expectation of x here is 1 minus p divided by p, which is 0.95 divided by 0.05. And if we calculate that, we'll find that that is 19. So in other words, the 20th one would be the first expected success, because remember, what we are counting is the number of failures until we get the first success. Now we'll see when we use the class pad that the class pad does that differently. So whereas we would call this situation x equals 4, the class pad calls this situation x equals 5, counting the first success. Now I could just simply change and do the same as the class pad, but you have to be aware that both versions of this distribution are out there. So if we move on, find the probability that there are 4 correctly fitted thingies before she finds an incorrectly fitted thingy. So as far as we're concerned, we're calling that x equals 4 because we've got 4 correctly fitted ones first, 4 failures first. And for us, that is 0.95 to the power 4. Those are our 4 failures. And then we follow that off with a success. And so we just need to calculate that. And so we get 0.95 to the power 4 times 0.05. And that gives me, probably better off in decimal, 0.0407. So 0.0407. Now I said the class pad can do this, and indeed it can. If I go to interactive discrete distribution, you'll see Geo is here, and in this case single value, so we're after a PDF. And the class pad goes one up, so it includes the success. So in other words, where we said it was x equals 4, we need to say 5 when we're on the class pad. Probability of success, of course, is 0.05. And you see that you get the same value just there. Find the probability that the first incorrectly fitted thingy is the 12th. And therefore, we have 11 incorrectly fitted ones first. So we're looking at x equals 11. And that would therefore be 0.95 to the 11 times 0.05. And we can just edit this one here and make that 11. And we get 0.0284. And here we can edit this one as well. And of course, it's one up from ours. We called ours 11. And so the class pad calls it 12. And there you go. That's the same answer you can see there on the class pad. Find the probability that there are between 10 and 20 inclusive, so there's altogether, for 10 to 20 inclusive, there are altogether 11 probabilities in there, correctly fitted thingies before the first incorrectly fitted thingy. Now, how would we do that without the class pad? Or at least just for doing manual calculation? Well, we can do it because what we're after here is the probability that x is equal to 10 plus the probability x is 11 plus, and so on, up until we get to x equals 20. Now that's 0.95 to the power 10 times 0.05 plus 0.95 to the 11 times 0.05 and so on up to 0.95 to the 20 times 0.05. And we can take out from there a common factor of 0.95 to the 10 times 0.05. And if we do that, we then get 1 plus 0.95 plus 0.95 squared, and so on, up to 0.95 to the power 10. And what we have here is a geometric series. And that geometric series has a first term of 1, and r is equal to 0.95, and it has 11 terms. So in other words, the stuff I've underlined in pink here can be evaluated using a 1 minus r to the n over 1 minus r as 1 take away 0.95 to the 11 over 1 take away 0.95, which of course is 0.05. So what we have here is 0.95 to the 10 times 0.05 times 1 minus 0.95 to the 11 divided by 0.05. Those 0.05s cancel. So it's just 0.95 to the 10 times 1 minus 0.95 to the 11. And if we calculate that, it comes out to 0.258. Now, of course, we can do this on the class pad. So let's just have a quick look at how that would work on the class pad. So what we would have is discrete distribution, and it would be a GeoCDF this time. Now, we were looking at it being 10 to 20. ClassPad goes one up, so it's 11 to 21. Probability of success is 0.05. If we OK that, 0.25817, supposed to be consistent. I ought to call this 2582 here, because I normally round to 4 decimal places for probabilities. And so you can see how that is done. And then finally we have part E. Find the probability that the first incorrectly fitted thingy is the 13th, given that the first 8 have been correctly fitted. So what we have here is a conditional probability. Now, if the 13th is the first correctly fitted, we're looking at x equals 12 because the first 12 must have been correctly fitted. And the first 8 have been correctly fitted means we're looking at x is more than or equal to 8. Now, with conditional probability, the probability of A given B is the probability of A and B divided by the probability of B. So this one here, well, for both things to be true, it's just simply the probability that x is equal to 12. And on the bottom, we've got the probability of x being greater than or equal to 8. So let's look at that idea of the probability of x being greater than or equal to 8. That must mean that we have the probability of x being equal to 8 plus the probability of x being equal to 9 plus the probability of x being equal to 10 and so on forever, which is equal to 0.95 to the 8 times 0.05 plus 0.95 to the 9 times 0.05 and so on, essentially forever. So we've got a 0.95 to the 8 times 0.05, which we could take out as a common factor. And then we'll have 1 plus 0.95 plus 0.95 squared, and so on. And this part just here is an infinite geometric series. So we can do the sum to infinity, which of course is a over 1 minus r, and in this case that's going to be 1 over 0.05. So that is going to cancel with that, and essentially we get left with 0.95 to the 8. So going back up here, we've just established the denominator is 0.95 to the 8, and the top, of course, is 0.95 to the 12 times 0.05. If we calculate that, it's 0.0407. So what could we do on the class pad? So what we could do is, well, first thing, let's give ourselves a fraction template. And then the top is going to be a GeoPDF, just a single value. Now remember, it's 1 up on this one, so that's 13 that we want rather than 12. Probability of success 0.05. Click OK. It's not going to like it because all we've done is filled in the numerator there, but we're going to put the denominator in now. And that is a CDF. And we're saying it's greater than or equal to 8. So the class pad is going to want it to be 9 because it goes 1 up from us. Now, it doesn't like it if you put infinity in here. So just put in a big number. The probabilities will get so small when you get out to something like 1,000 that it really doesn't matter. Probability of success is 0.05. And OK that. And you can see you get the same answer.